Hello, Algebra 2. We are getting deeper into the world of trig identities. You're going to get a bunch of new identities here, and I recommend these are going to be, we're going to be not using a graphing calculator or any kind of calculator with these, so you want to have a unit circle handy, and preferably the unit circle that also has your 30, 60, 90 triangles worked out. So I'm just going to kind of point out, here are three identities where sine of an angle, call it A, plus another angle B, the identity is not the distributive property. And we're not going to go through the derivation of this, so you're just going to take my word, but the nice thing is you also don't have to memorize these. I will point out a few things. So if it's a sine A plus B, notice that you have the same plus in between the two terms. So sine and cosine, sine A cosine B plus cosine A sine B. So if it were sine A minus B, everything is the same except these now become minuses. Still sine A cosine B minus cosine A. And again, you use the identity, not a distributive property. If it's cosine, so we have cosine A plus B. Notice the cosines stay together, cosine A, cosine B, and you have the opposite sign of what was in the parenthesis. And then sine A, sine B. Same is true for if it's cosine A minus B, then this has the opposite sign. But the cosines stay together, cosine A, cosine B, and the sines stay together, sine A, sine B. Then you have your tangent, and this one becomes a ratio, and it looks like on the numerator as if you distributed. So you have tan A plus tan B, the same sign, and then downstairs 1 minus the opposite sign, tan A times tan B. If you're subtracting, if it's tan A minus B, so again, it looks like distributive on top, tan A minus tan B, and then 1 plus. So you always have the opposite sign, numerator to denominator. So our main goal is for you guys to know how to use these. You're not going to be memorizing them. All right, so how do you use them? Well, before I get too far along, I want to put up here your 30, 60, 90 triangles, because we're going to need this as a reference. So 30, 60, so this was 1, this is 2, this is rad 3, and then you had your 45, 45, or if this is 45, that's 1, 1, rad 2. Okay, it's actually better though if you have your unit circle handy. And remember, cosine goes with your x values, sine goes with your y values. So how do we do these? How do we find the exact value? Because you're not supposed to touch a calculator with these. You're just supposed to expand it. No decimals. So we need to rewrite 15 in terms of like 30, 60, 45, some combination adding and subtracting, or 90 or 0, one of those. And so one of the easiest ways, again, there's more than one way to do these, but I'm going to write 15 as 45 degrees minus 30 degrees. So 45 minus 30 is the same thing as 15. Then what we do is we expand it. So we're using this identity right here, sine A minus B. So A is going to be the 45, B is going to be 30. So expanding it means I'll have sine 45 times cosine of B, which is 30, and then minus, same sign, and now it's going to be cosine of A, so cosine 45 degrees times the sine of 30. So you would expand it like that, and now we're going to substitute the exact values from our special triangles. Sine of 45 is opposite over hypotenuse, so 1 over rad 2, which rationalizes to rad 2 over 2. So sine of 45 is rad 2 over 2. Cosine of 30 is adjacent over hypotenuse, so rad 3 over 2, minus cosine of 45, which is the same as sine of 45, rad 2 over 2, and the sine of 30, opposite over hypotenuse, And so now we can just put it together. Notice they both have the same denominator. So I have rad 6 minus rad 2 all over 4. And that would be your answer. It's an exact value. That's why it has the radicals in it. There's no decimals. So that would be sine 15 without using a calculator. So let's do a tangent one, because this is going to require a little more algebra in the process. And again, there's many different ways you can get to 75, either through addition or subtraction. I'm going to use the same values and rewrite 75 now as 45 plus 30. And that would be then using this identity here, tangent A plus B. So first thing we want to do is expand it. So this will be tangent of 45 plus tangent of 30, all divided by 1 minus tan 45 times tan 30. All right, so now we're going to use our special triangles and substitute the values. Tangent 45 is opposite over adjacent, so that's going to be a nice easy one. That's going to be 1. Tangent of 30, opposite over adjacent, is 1 over rad 3, which we need to rationalize, so that's going to be rad 3 over 3. So rad 3 over 3, and this then all gets divided by 1. Why do I have this was a plus, sorry about that. Then 1 minus, tangent of 45 was 1, and tangent of 30 was rad 3 over 3. Well, that's really ugly. For one thing, we have a fraction over a fraction, it's called a complex fraction. So let's get rid of the fraction. Since the denominator in those fractions are 3, I'm going to multiply top and bottom by 3. What that does is it will distribute. So this will become 3 plus, and then the 3 will cancel over here, rad 3. And over on the bottom, I will have 3 minus rad 3. Okay. Now, unfortunately, you guys are not allowed to have a radical in your denominator, and I can't just multiply by rad 3 because I would then end up with still with a radical. So you're going to multiply by what's called the conjugate. I don't know if you remember this or not. The conjugate of my denominator, because that's who we want to get rid of the radical, is exactly what you see, but with the opposite sign. So I'm going to multiply top and bottom by 3 plus rad 3. So we're really multiplying by 1. We're not changing the value of it, but it is going to get rid of our denominator. So how does this work? We're going to FOIL the top. So 3 times 3 is 9. 3 times rad 3 is 3 rad 3. Then we work on the second one. So this will give me plus another 3 rad 3. And the last terms, rad 3 times rad 3 is 3. And we'll simplify that all in a second. On the bottom, notice I have a minus b times a plus b, the structure. That is your difference. That results when you FOIL it out in the difference of squares, a squared minus b squared. So 3 times 3 is 9, minus rad 3 times rad 3 is 3. Notice your radical goes away. That's why we multiply by the conjugate. So now it's just simplifying things. So on top I have 9 plus 3 is 12, plus I can add these two terms, 6 rad 3, all over 9 minus 3, which is 6. Now, you might think you're done. I know this is kind of a long problem, but notice that each one of these terms has a common factor of 6. So I can pull out that common factor of 6, and on top I'm left with 2 plus rad 3 over 1. These will cancel, and this is your final answer, 2 plus rad 3. A lot of work to get there. I totally admit. So the tangent ones are always going to have a little more because it's a fraction. You're always going to end up with a radical in your denominator, and it will require then multiplying by the conjugate. Okay, let's look at another example how we can utilize these. We want to find cosine A minus B given some clues. So the way these clues work is you're going to, remember I've talked in other videos about your bow tie problems. So this tells me where to draw, which quadrant to draw my bow tie. So A is in the quadrant between pi and 3 pi over 2, or 180 and 270. So if I were to draw a little coordinate system, here's pi, here's 3 pi over 2, so the triangle is going to look like this. Remember, it looks like one of your bow ties. So how do I use these clues? So this is the triangle for A, and it says cosine A is negative 4 over 5. Well, that's your adjacent over hypotenuse. Your hypotenuse is always 100% of the time positive. So this is the 5. The negative 4 goes here. Using Pythagorean theorem, we know that, because we need to find this opposite side here, this is a 3, 4, 5 right triangle, but in the third quadrant, this is going to be a negative 3, because that's your y value. Now let's do B. We can actually put B. I'm going to, this is in my way, okay. I'm going to draw triangle B is from 0 to pi over 2. So here's 0, here's pi over 2. So I can draw my other bow tie. This is going to be for triangle B. And the clue is that the cosine of B is 5/13. So the hypotenuse is 13, the adjacent is 5, and you can do your Pythagorean theorem. If you don't remember that this is a triple, it's a 5, 12, 13. So I'm just going to go ahead. And in this case, because it's the first quadrant, everything is positive. All right, so hopefully that's okay. So all this over here was just giving me clues to set up my triangle and using Pythagorean theorem to find the remaining side. So now I'm going to expand cosine A minus B. So we're using this formula up here. This expands to cosine A, cosine B, plus, because of that minus, it's always the opposite sign, sine A, sine B. So you're like, okay, that's nice. Now what do we do? Well, I go to my triangles and I just substitute. And some of this you don't even have to go to the triangle. Cosine of A, well, that was given to us. That's negative 4/5. Cosine of B was given to us. That's going to be 5/13. Plus, for the sine, I have to go to my triangles. The sine of A, that's the green triangle, is the opposite over the hypotenuse, so that's a negative 3/5. Sine of B, that's the purple triangle, is opposite over hypotenuse, which is 12/13. And now we just simplify. So we have a negative 20 minus 36 over 5 times 13, common denominator. And so this results in negative 56 over 65. And if you can reduce, you should, but in this case, that's as far as we can go. All right, so you use the clues to draw the triangles, Pythagorean theorem to find the third side, expand your identity, and then just substitute in the ratios from your triangle. All right, let's look at how we can simplify an expression using your identities. So cosine x plus pi. So cosine, we're going to use that second one up here. So this is your A and this is your B. We're going to expand that. So that's cosine x times cosine pi minus sine x times sine pi. Now it's going to be helpful if you have your unit circle, but let me go ahead and remind you here at pi, if I had a unit circle here, this coordinate is -1, 0. So remember, cosine goes with the x, sine goes with the y. So cosine of x is just cosine x, can't do anything about that. Cosine of pi is the x value, so that's a -1. Sine of x is just sine of x, can't do anything with that, but the sine of pi is 0. So this whole term just cancels to 0, because 0 times anything is 0. And this whole expression now simplifies to minus cosine x. So we have simplified it down, so it has a very simple argument, just minus cosine x. Okay, now, introduction to solving. Solving an equation, and we're only going to solve it within one rotation of your unit circle. So this might be handy time to go grab one. I know I put some already filled out ones on past worksheets, and you've already should have filled one out. Or you can always just Google it and print one out that's already filled out. So what we're going to start by doing is expanding these using the identities. So sine x minus sine of x minus pi over 2. That's going to be, here's your A, here's your B. I should probably keep your, where you can see your identities up here. I was trying to give myself a little room here. So this is going to be sine x, sine, sine x cosine pi over 2, sorry, I almost made a mistake there, minus cosine x times sine pi over 2. All right, so that expanded there. I'll do them in different colors so we can differentiate. Then we have a plus, and we expand the cosine. So this one will be cosine x cosine pi over 2. And then since this is a minus, we're going to do a plus sine x sine pi over 2. And this all will be set equal to 0. And you're like, what? How are we going to solve this? Well, first thing we're going to do is evaluate wherever we have a number to start with. So up here at pi over 2, remember that's 90 degrees, that coordinate is 0, 1. So cosine, which again is the x value, cosine of pi over 2 is going to go to 0. So that means this whole term just goes away. Sine of pi over 2 is going to get replaced with 1. Cosine of pi over 2 again goes to 0, so that whole term will go away. Sine of pi over 2 gets replaced with 1. So what do we have here? We have minus cosine x, that's from right here, times 1, plus sine x equals 0. So what you might want to think is like, okay, how do we solve this? Well, how about if we add cosine to the other side? So what we're actually solving is sine x. Where does sine x equal cosine x? Remember, sine is the y coordinates, cosine are the x coordinates. So when you look at your unit circle, where do you see the x and the y coordinates being identical? And hopefully, if you're looking at your unit circle, you should see a coordinate like this at 45 degrees. And then you should see a coordinate like this. And that one occurs at, actually I should probably put this in radians, so that's pi over 4. This one is going to be at 5 pi over 4. 5 pi over 4. And since there's where sine and cosine are equal, that's going to be your solution. So x equals pi over 4 and 5 pi over 4. Congratulations, you just solved your first trig problem. So we really are dependent on using the unit circle to find those values, because you're just doing it within the one rotation and looking for where sine and cosine were congruent. Okay, hope that helped.